soil biomes, sea biomes and stuff. And then we did such a research. And then I'm going to dive deep sea in this November and to hunt new phages. So actually I'm doing many research. And then last weekend we had a bacteriophage meeting in another university. This is a photo of all of them. And so I just know the bacteriophage probably. Of course, I doing the lecture as well, so I know a bit of the microbiology, but I specialize in the bacteriophage. And recently, bacteriophage is growing. I mean, in the research as well as education as well, because bacteriophage grows so fast, so it's very suitable for the practical. So, people can isolate the bacteriophage from the environment very easily. So it's not, it is actually different from a human virus, like animal viruses. So it's pretty a simple thing, so easy stuff. So actually I use the bacteriophage to teach students how a bacteria grows and how viruses infect the bacteria. So it's same as animal viruses. So probably people can use as a model. How can I say model for the coevolutionary arms race between virus and bacteria. Okay. So now I'm starting the practical. I'm going to introduce the bacteriophage. Bacteriophage, as a short, phage. It's a bacterial virus. It is known that bacteriophage is the most abundant and diverse life forms on the earth. So researchers discovered the on the earth there are 10 to 31 virus particles in the environment. So actually it's like heaps, all right? And to isolate the bacteriophage, 96% of the this type of phage, it's called a tailed phage. Probably you guys learned from the bacteriophage from the textbook. Probably people know this structure, head and tail. In the head, there is the genomic DNA. It's a double strand. Okay, that's the general feature. And there are several types of bacteriophage. Based on the morphology, we are going to classify these phages. So for example, this phage has got a long tail, head and long tail. This is it can be classified in family Cephalidae. And this has got a short tail. You may not see these things, but there's a tail. Head and short tail, it's classified into the family Podobitidae. And the other is the head and rigid tail. It's contractile. It's it's like a syringe. It's moving and things. It's called the family Myobitidae. So based on the tail structure, generally a bacteriophage can be classified into 3 families. Okay, just a classification. So it's not important, but to understand the bacteriophage, you need to understand the life cycle of bacteriophage. So it's called the lytic life cycle. Of course, as a name, bacteriophage has got a lytic activity. So bacteriophage can adsorb onto the bacterial surface and they inject the phage DNA, and then phage multiply and make progeny phages. And then at the end, bacteria is burst and spread the proteophages. So as a result, bacteria died. The other life cycle is the lysogenic life cycle. This life cycle is similar to the retrovirus, and then bacteriophage are absorbed onto the surface of bacteria, and then inject its DNA, and then phage genome actually they integrate into the host genome, the host bacteria genome. So it is a site-specific integration. So some bacteriophage has got like random insertion activity as well. So depends on the bacteriophage has got the which enzyme. Like for example, this type of phage has got the site-specific integrase. So using the enzyme, bacteriophage can integrate site-specifically or randomly. Okay. And as a part of the host genome, phage multiply genetically. This is called the lysogenic life cycle. This is a summary of life cycle. What is a lytic life cycle? It's obligate. Some bacteriophage has got obligate lytic life cycle, and some has got the both. So integrated bacteriophage can be stimulated by UV and as well as antibiotics or mitomycin C, like anti-cancer drugs and stuff. So imagine like people use a lot of antibiotics. Probably a lot of clinicians don't know why bacteria died. Some antimicrobial activity caused by this bacteriolysis caused by a bacteriophage. Of course, we need to notice the bacteriophage can transfer the pathogenic genes. So, for example, cholera toxin converted by a bacteriophage. Botulinum toxin is converted by bacteriophage. Okay, so as a part of the gene, some bacteriophage has got the pathogenic genes or toxin genes, and then this phage goes into the lysogenic life cycle, and this bacteria can arm the production of the, for example, the toxic production of toxin. So you may know the probably essential coli 017. The toxin is actually converted by bacteriophage. Okay. Back to the lytic activity, lytic life cycle. We can detect the bacteriophage lytic activity using just such agar plates. This is a simple procedure to detect the bacteriophage. It's called a plaque assay, and this white things is all bacteria, or the bacteria overgrowth. So it's actually turbid, and this hole is actually transparent, and it's called a plaque. And one virus is infected the bacteria and spread and make this hole, and this is called a plaque. So there are several types of plaques. This is small plaque. Some bacteriophage can form the this large plaque. This is my actual experiment, and I introduced just one genetic mutation, just nucleotide exchange, and then phage can form this big plaque. So you see the difference, right? So bacteriophage can evolve so fast. And then you can observe the bacteriophage using the turbidity. So in a microbiology practical, probably people can grow bacteria in a liquid media and using optical density to observe the bacteria. And then to teach students, you can differentiate between bactericidal, bacteriostatics, and so on. And then, as you know, this probably you guys noticed that this is a control. So we don't add any antimicrobial agents. So the bacteria grows nicely. And then at this point, actually we added the bacteriophage, and then bacterial growth is stopped and then it goes down. And at this point, we added the antibiotics, for example, rifampicin, vancomycin, oxacillin. So you can see the static curve, right? So you can teach the students difference between such a activity and explain the mechanism of that. And in the worldwide, people use the bacteriophage in the States or Europe. They use the bacteriophage as an education material. For example, one of the big project is called C-phages. This is the States program to teach bioinformatics and microbiology and virology. And actually, the States invest the educational program to search for the new phages. And actually, this is one of the undergraduate program, and then people through the undergraduate program, students can learn the bioinformatics skills and how to isolate the bacteriophage and how to use the bacteria. So it's a very cost-effective way to teach microbiology, they said. And as a result, they published such a good paper. They collected tons of bacteriophage and sequenced them, and then reported in eLife. This eLife is impact factor is I think 9 or 10 or I forgot, but okay. Now this is my part. I'm doing just a simple practical today, and we have a limited time, so we just observe the bacteriophage lytic activity in this practical. And then purpose of this practical is this is to teach the students bacterial growth and the liquid media. So using the concept of the optical density. And then of course you will expect to observe the bacteriolytic activity. So you can teach how viruses multiply and bacteria grow. And of course, to extend this practical, you can teach the coevolutionary arms race. And of course, you can teach the students bacteriolytic, bactericidal, and bacteriostatic activity. Okay? Okay. So now we are going to do a practical, and then this to present this practical, I always say the simple way. So why students need to do this practical to the students? So Phase-lytic effect is examined by a measurement of bacterial stability. Okay. So this part is very simple. Actually, I prepared your table. Okay. Okay. And probably this is written in Japanese. This said the biohazard rubbish. Okay. And this is lighter to do the aseptic I forgot the word. Aseptic to turn on the burner. Okay. And this is a pipette man. Tips. Okay. This is alcohol to disinfect your hands. Okay. We have these things to do the practical. So I thought to hand out, give you these handouts. Okay.
Yeah.
So before starting, please come and get them. Okay.